This is the second part on congruence, of understanding congruence through transformations. And we were looking at how can transformations be used to determine congruence. We looked at last time how a figure can be moved around and end up falling on top of another figure, and that we can show that it's congruent. We have to remember that congruence means equal to. All right, well, we're going to kind of take a look at another way to show congruence, and that's through dilations. Okay, now it says dilation changes the size of a figure, but not the shape of a figure. In other words, it's going to stay proportional. Okay, so in order to define a dilation, you must find the center of dilation, which is the center of the figure, and a scale factor, which is the number used to multiply the vertex to get the figure. Now there's two ways to look at the figures, obviously, if they're going to get larger, if they're going to get smaller. So if the scale factor is greater than 1, the dilation will enlarge the original figure. If the scale factor is between 0 and 1, the dilation will shrink the original figure. So we know, based on what's happening from the pre-image to the image, what our scale factor should be. So again, if our pre-image to the image gets larger, our scale factor has to be greater than 1. If from our pre-image to our image gets smaller, that means we're going to have a fraction as our scale factor. So let's take a look at a particular arrangement here. So we have triangle ABC, which is the pre-image, and then we have A prime, B prime, C prime, which is the image. Let's record what our ordered pairs are for these two triangles. So if we take a look at triangle ABC, we see that point A is at 1, 1. We see that point B is at 1, 3. And point C is at 3, 1. We do the same for A prime, B prime, C prime. We see that A prime is at 2, 2. B prime is at 2, 6. And C prime is at 6, 2. Now what we have to do is think a little bit. We need to look at the relationships between the points. We can see that on point A, the x's went from 1 to 2. Now we know with the scale factor we need to be multiplying. So we think 1 times what gives us 2? Hopefully we all think the number 2. We can check that over here. Is 3 times 2 6? It is. So we can see the scale factor on the x goes by 2. And it is enlarging, so we do want a number greater than 1. So we're going to put a 2 in front of the x here to represent that it's going to double. We'll do the same thing with the y's. We'll take a look at the y's. The y's go from 1 to 2. Again, that's giving us a clue that it's possibly by 2. And then here, 3 to 6, again, it's by 2. So that looks good as well, so this is 2. Now this is what we call the scale factor. This number 2 becomes the scale factor. And you notice that the number is the same in both positions. We can verify this also by looking at sides. We can see here the side length of AC is 2. The side length of A prime to C prime is 4. And it's doubling, because 2 times 2 will give us 4. Same thing with AB. This side is 2. A prime to B prime, this side is 4. And again, 2 times 2 is 4. We see it doubling. Now, one thing to remember, in order to establish congruence, which means equal, and that means they have to be proportionate, these numbers here, the scale factors on each, the x and the y, must be the same. Now, there's a really cool video on YouTube. It's called Scale Ella. And you can click and go to that. And it's a little cartoon, and it talks about how things are enlarged and how things get smaller. And maybe we'll hopefully bring a little more ideas and emphasis, and so that you can understand dilation a little bit more.